goal is with your teammates, work through these problems. So don't skip something just because it doesn't like have a picture or something. We have directions. List some of the equations you've been working with in the past 2 lessons. So give a couple examples of like a positive slope, a negative slope. We haven't really seen negative slope. Huh. Negative slope. It's an interesting thing to think about. Y-intercepts of 0, right? So if it's a y-intercept of 0, there's no plus, right? It's just like y equals mx. Then, okay, we just talked about this. So on your paper, you're going to write m is the, b is the, and then you're going to look at this graph and identify what would its equation be. You don't need to be doing anything right now. I'm running over the directions really quickly, right? Then you're going to look at this table and determine what the equation would be. Same with these tables. Obviously a little bit harder than this one because this one tells us the growth. And then I think this is the last problem. We have the rule given to us, which I said we want to soon stop saying rule because I don't like the word rule. And then they give us some information. Right? So I'm not going to say too much about this because I don't want to give things away. And then I think that's actually, yeah. So obviously we don't do the learning logs. I normally just don't do that. So that is what we're doing. You are working from up to, your goal is get to problem 35. And we are starting back here and just listing some equations. And guys, 30 and 31 can go together. Write down some equations and talk about this has growth of whatever. This starts at whatever. Do my directions make sense? Awesome. The only way I can turn music on is if we can handle it. So if you stop being able to handle it, the music gets turned off. Go ahead, Max. What's up?
When you say list some equations, what would those
like look back in your notes, right? Like the things like that resource page that I gave out, equations that we created from there, or equations from your homework. Are you okay? What's up?
There are no regular pencils over there. These are all like
I got you. You're doing exactly what you need to do. So let me know. By the way, where's Aiden? Oh yeah. You surfing. Sorry. What's up? Parameter. So thank you. I was waiting for somebody to ask about the syllable pronunciation of this word. This word up here is parameters. When somebody gives you parameters, parameters are numbers that stay the same in the equation after they are chosen. So your parameters are like m and b, right? So our slope stays the same, our y-intercept stays the same, but x and y change as we go, right? As we change x, we change y. So we need a book. So if we don't have a book, we need to grab one from up front, or go grab one from the locker. And a book, a couple books, and a book. Christmas. The tradition in my house is ball up your wrapping paper and throw it at my sister. That's our tradition, and by about halfway through, she gets very mad at us. Right. There you go. Yep. We only had cats at my parents' house, and now I have dogs, and I like that. Good strategy. Hey, I'm just going to come out and say it. I plan to give you guys a mini mastery relatively early next week, maybe even Monday. So if you don't know how to do any of this, we should ask questions. So, parameters is just a fancy way of saying the slope. Once we figure out what the slope is, slope stays the same. The y-intercept, once we figure out what the Y-intercept is, it stays the same. So like these equations we did yesterday, as you move up the line, the slope doesn't change, and the y-intercept doesn't change because we're moving up the line. We're moving at the same slope, we don't change the right? And we're moving from the same y-intercept. So when you formalize an equation, like up here, you said y equals 4x plus 2. The 4 doesn't change and the 2 doesn't change. But as x changes, y changes. As x changes, y changes. Right? So when x was 1 versus when x was 2, x changes. When x was 1 versus when x was 2, so as x changes, y changes. That's what it means. Parameters don't change. The 4 and the 2 don't change. Yeah, the 4 is a parameter and the 2 is a parameter. Slope and y-intercept, those are parameters of your linear equation. Those are what? Basic? M? Well, we've been calling it slope, but what does it really mean? Growth. Really, right? It's the growth as we move forward. Or I might want to pull everyone together to talk about this. Hold up. Yeah.
What is number B? Is it the integer? What do we call it?
We're going to do this problem together because I realized we should probably chat about this. In 30, there's no real right or wrong answer for 30. Sorry, I said I was going to let you go and turn on music, but then I got all the same questions very quickly, so I realized we should just do this together. Write down 31 on your graph paper. Write down 31 on your graph paper. Right, so your graph paper should have a header of y equals mx plus b. Jake, when you walked in the room, I said that as I typed it on the screen. What that tells me is you were not listening. Let's fix it. Be better next time. So, sorry, I meant to write 31 down here, but then Jake distracted me. So, yesterday, and you guys probably turned this in already, so that's why I'm going to remind you of it. Yesterday we had these tables, and we ended up, some of us on our papers were writing the rules kind of like this because we saw the growth was consistently 4. So when we talk about y equals mx plus b, they say m and b are parameters. And if you pronounce it wrong, it sounds like parameters. What that means is in an equation such as y equals 4x plus 2 that we dealt with yesterday. Sorry, I should full screen this. Yeah, but now what, say more than saying it's m. What did we say the m is? So as we move up the line, as we move up this line, the slope doesn't change. The y-intercept we started at does not change, but as I move, when my x is 1, my y is 6. When my x is 2, my y is 10. Right? When my x is 3, so x and y continue to change. But the 4 and the 2 in my equation do not change. X and y are going to change. So 4, write down multiple words here. So we call it slope, but it's also the growth. We can say it's the delta y divided by the delta x if we want to get fancy. I mean, that's up to you. It's Friday. I'm feeling Friday fancy. And the 2 is what we call Y-Intercept. That's like the formal name. But it's also, it is also what y equals to when x equals 0. If you want more clarification on what the Y-Intercept means, Means on the y-axis, we're going to be at 2 when x equals 0. It also tells us the point 0, 2 is part of our table or whatever we want to talk about. It's also the amount we have. Hang on, one more and then I'll take your question. It's the amount we have in figure 0, right? So that is our figure 0 amount. Max?
So basically, like the Y-intercept, basically just like intercepts the Y's of going through 0.
Yeah, instead of going through the origin, it hits the y-axis. Now, if it goes through the origin, and I would have written plus 0, do I need to write plus 0? No, that's silly. Let's not be silly. All right, so now you got 31 done. You should be ready to move on to 32 with your partners, and I think at this point I can probably turn on some music. Really? Bollocks. Did I do? I did. That's because I made that table. Which one is that? This B. Hey, friends. I'm a bad teacher. This is a typo on your paper. Because I had to make these tables. I don't know why I didn't just like copy it out as a picture. You need 414? You need a copy of 414? We're doing some problems on there. Guys, reminder, if you don't have 414 out, you should. Some of these problems are on there. 33 is on your paper. That's why I'm notifying you of a typo. 33 is on your paper. So 32 you're doing on graph paper, but guys, 33 is on your paper I gave you. 33, so do 32 with your team.
Oh, we knew you were gonna play this in band. Yeah, we played this in band. This is not how we
So if you look at this table, we got to determine what is the slope, what is the y-intercept. We're going to write that down on our graph paper. What do you think? How much growth is there every time you step over the line? And then what's the y-intercept? Yes.
What?
I still barely know what happened. Like, I'm not on figuring out how to know. Yeah, I had to learn that from this hour. What happened? Alright, I'll make sure you know what's up. As you go to our page, why you think you know what slope? It's how much growth occurs when there's one step of growth occurs. Yeah, so then from 1 up to 4, so our growth is 3. So we know that's going to be our m. So I pointed out, that's going to be our m. We're going to write 3x. And then what was our y-intercept? There you go. Yep. That's going to be one of the next ones. Did we get 32 figured out? Yeah. You got off 32? You know, this 33 is on your paper. I literally just said that and I put it up on the board and I said, this is on your... Like, literally, if I open this, now I put my other paper on top of it. I did not tell you guys to turn in 414. Guys, if you're not looking at your 414 homework paper, or if you don't have one, I have extras, but 33 is on your paper here. But, okay, I gotta pause this. But all the people that weren't listening when I said it, this should be a 3. I don't know how I have that typo. Should be 0, 1, 2, 3, 4, 5, 6. Are we all good now? You need it?
Okay, Elvier's nice sometimes. Oh, he's seen now!
They must have fixed it on the online bit now, because it's right now.
My pipes look
Hey,
like
are you handling yourself all right?
Yeah.
Because I hear you over top of everybody else. We're 32. So I think I've made it all the way around to check that we all have this. Yeah, I can't pause from over here. Alright, so I think we all made it through this problem. When we look at, they actually were really nice to us here, and they gave us what's called the growth triangle. So the growth triangle shows us how far we go over on the x and how far we go over on the y. Now guys, I know you're going to think this is silly, but please, on your paper, by 32, write delta y over delta x. How we figure out the growth in not nice situations is make a triangle that connects 2 points. So the triangle they gave us is an option, but we could also make this triangle, and it would actually be 6 compared to 2. So if you want to make an example on your paper of how to determine your slope, it's the change in y over the change in x. My y went up by 6. If I look at the big triangle here, this triangle, it went up by 6, went over by 2. But this reduces to what? To 3.
Oh, so that's the...
So anytime we can draw a triangle, put your rise over your run. How far up over how far over. The blue one was nice. It was 3 to 1. It was great. But if it's not nice, do the division. Or leave it as a fraction. Slope is often given as a fraction. All right, keep going.
Okay, so we're using your... Oh, A is like really... That's different.
Yeah, there's 412, then there's 403.
Negative 3x.
This is
Man, I gotta check the schedule. Make sure that our classes are at the same time.
I'm like...
Somebody's watching me. Oh man, the microphone's pointed right at me. I always feel like somebody's watching me.
I'm sorry to anybody who wants to listen to this.
Nobody has to listen to this. I think Christmas, but
yeah, Christmas and then Halloween. Like if you're talking about theme music,
What problem do you want us to add?
do the whole thing, 35. Up to 35. Anyone need more time for 33A, or can we go over it? Anyone need more time for 33A? All right, time for random cards. Ooh. Time for random cards. Sorry, maybe you volunteered yourself so often that I skipped your card. That does happen. Because if you've already spoken during class and I already know what's going on, I sometimes, skip over. So, Connor, what did you guys figure out for this table? You want to go ahead and throw me an equation, or what do you know? Sure. So we're going to say y equals, right, 5x minus 2, or we could have said plus a negative 2. But what this lets us do is even when we don't have a table, if somebody says, hey, what if x is 6? We would substitute it in. What's 5 times 6? 30 minus 2?
28.
So this, you should have a 28. And everything else in the table should correspond with the rule of adding 5 every time the x goes up.
It's just 3, 8.
Sure, if you want to fill them in, 3, 8.
And we're like, it's like 3, 8, 3, 8, 3, 8, 3, 8.
What?
It's like the last digit is.
Oh, yeah, because every time you add 5 twice, you add 10, right? Do we need more time with B? No? All right, so Walter, what about here in BI? Oh, wait. So, do we want more time on this? So, let's do this together then. So, Walter, since I just called on you, do you want to help me with the growth here? Plus what? Plus 2 is our growth. So, guys, on your paper, draw arrows like this. Right? This is how we look at growth. But, always double check. Guys, this is critical. I would like you to put this on your paper and make some sort of alert. Always double check that x is just going up by 1. As long as x is just going up by 1, then we can just say that this is our growth. But if x changes by something that is not 1, we have a division we're going to have to do.
Division.
So then, Max K, you can answer this or you can skip it. How can I look at this table and figure out my y-intercept? Yeah, chill. Skip, totally fine. Gus? Did you hear the question I asked, or should I ask it again? Y-intercept. How do we look at the table and identify the y-intercept?
Well, you find 0 on the x.
0 for the x. I look at my x's.
So
I find 0.
And then the positive, and then you go to the y, and you find out what the y is. If it's positive, plus, and if it's negative, then you do minus.
So like we wrote on our graph paper, when x is 0 tells us our y-intercept. So this becomes y equals 2x plus 5. So Renal, if I look down here at the double I table, what's our growth? Growth does not have to be positive. Growth is just a term we're using as we move forward. Did you say we're dead? So, minus 3, right, or negative 3. Our Colin's not here today. Patrick, what about our y-intercept?
Our y-intercept would be 7.
Y-intercept would be 7. So, class, what's our equation here? Ooh, careful. The growth is negative, but the y-intercept is positive. We could also, if you want to write this a tiny bit cleaner, it doesn't matter. You can do that as well. If you want to put your negative in parentheses. Hey guys, when you all ask questions at the same time, it doesn't work very well. Hey, look, a hand.
This is something that I just did that made me have a bit of a different answer in my that, and then I didn't know how to write it. It's that if you add every single one of like the top and the bottom together, you get a -2. So 0, 7, 7. 1 and 4, 5. 2 and 1, 3. 3, -2, 1. 4, -5, -1. And it keeps.
That's a cool pattern.
It keeps minusing 1. It keeps minusing 2 if you add the top and the bottom.
If your brain can't like deal with what he said, just block it out. Just Men in Black, Flash, and just forget it. You're seeing really cool relationships. I can't go down that rabbit hole right now because we'll get stuck. Like, we won't be able to climb back out, probably. At least some of us.
I'll get you a ladder.
Like, I want to very much say I totally respect what you just said, and it's cool, and it's true. We're not ready to talk about that yet. But if you want to keep in...
Say something that proves I'm a child genius.
If you want to keep investigating that on your own, I encourage you, as we look at more and more and more patterns, try to figure out why what you just noticed is happening.
Why?
Why?
Because the why is
You're not even trying that time either.
I also wasn't trying when I did the carve out time for pumpkins.
Yeah, that was funny.
On 34, they give us 4x plus 3, and I'm going to turn on music again in a second. But guys, be careful. Wait a minute. Do we know what this looks like?
No.
You can make this look like whatever you want. But start with figure 0 to make your life easier so you can determine some sort of shape I start with. And then I'm going to add things every time. How many am I going to add every time? 4 is going to get added every time. Guys, give me your eyes up here. 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 Thank you. The trap door is this, making people think that that adds every time. It does not. So if it helps you to write now, write things like start at 3 and add 4 however many times I need to. This is the same as that. Absolutely the same. 4x plus 3, 3 plus 4x. I start at 3 and I add 4 however many times I need to. So you get to draw this however you want. You could like make it be like a person or whatever. Just make sure that the growth would be able to be identified by somebody else. And then B is separate, right? B is a separate question asking you to make a tile pattern that is decreasing by 2 every time. And figure 2 has 8 tiles. That's a bit trickier. Because I don't know what figure 0 or 1 have. They tell me what figure 2 has. They tell me what the growth is. So these are on graph paper, right, guys? These are on graph paper. Sure, absolutely. Who knows this song yet? Nope.
Oh,
I'm not surprised if you know it.
I was raised a generation before I was born. Of course I know this song.
What is it? Or what's the movie?
I don't know the Max.
I don't know. Max?
You know. Wait. Dang it!
It's the Time War.
I know
It's like another dancey type song thing. It's in this movie, they all dance to it. It's like Thriller when everyone dances to it.
Wait! Is this Back to the Future?
Alright, do the math. Math. You guys get to be creative here. Make it look like whatever you want. I don't know, man. You are
I thought it was a different song.
Literally just
Hey. Alright, I'm gonna make my pattern.
Make
Shh. Don't steal my idea. Because add 4 appendages, right? I'm thinking 4 appendages.
I was just trying to be as efficient as possible, and then let go where
Oh yeah.
I figure zero has no blocks. What?
Has to have three.
No, it has to have three.
Yeah, for the figure zero, that's not three. It doesn't matter.
It has to have three. Yeah.
Well, none of you guys know this song, so might as well skip it. This is from Hocus Pocus.
There's the Hocus Pocus.
We have it.
Travesty.
I haven't seen it either.
Yeah,
It's
and I
so
think
good.
that we watched it.
I'm gaming.
No, I know anyway. I saw current and
All right, as soon as I.
So, as the brilliant suggestion given to me, if you wanted to color code and if you wanted to make this look kind of fun, I'm making a person. Right, so my dude's arms are getting longer and his legs are getting longer because it's +4 every time.
His arms get surely the boogeyman song. His arms have perpetually a very small body.
Alright, is this making sense?
Yeah.
B's the harder one. I'm going to copy this page out so I can keep A there. For problems like this, where they gave us the growth and they gave us one of the things, man, make a table. Now the only reason I'm going to go horizontal is because my screen, but I would normally go vertical. Just vertical tables seem to work nicer. 0, 1, 2, 3, 4, 5.
Mistakes are how you learn.
What can I fill in on my table?
2.
What about 2?
8 tiles.
That figure 2 has 8 tiles.
Yeah.
And what then can I fill in? Everything else. As I move forward, I decrease by 2 tiles.
It means the other, if you're going to 1 and 0.
I do not know it. This is on some Hocus Pocus playlist.
Play a
Halloween by Hospice, Maine.
Yeah, play the boogeyman song from Nightmare.
So wait a minute.
Where
What's
was London?
what's my Y-intercept here?
-2.
Because as we
Oh, wait.
go backwards, we actually go up. So yeah, this in B, we actually get y equals -2x plus 12.
Can I go by twos if I don't have enough? I didn't do what math said. If you look at 0, 12, that's 12, next one goes 10, 11, and 9.
So wait, Aharon's taken Max's idea, and Aharon said, look, add these 12, add these 11, add these 10, add these 9, 8, 7. Interesting.
6, 5, 4.
All right, that is all the time we got today, guys.
I was making up something.
I need to take so
It's pretty much too late because I already have too much music.
No.
But what's the song? It's probably already on there. What? Rockefeller Street? Are you sure you're not talking about Rockefeller Stang?
No, No, not still.
I'm saying that Connor said we
This? I'll have to listen to it later and make sure it's okay and see if it's danceable.
The one I have, it's the most danceable song I've ever heard.
Okay. I will check it out later. What? Oh, have a great weekend. Get out of here, guys. Get out of here. Unless you got a question for me, get out of here.